Today we are going to discuss problems related to Unit 1, Introduction to Electric Circuit and Magnetic Circuit. So let's move on to the first problem. First problem is given as find current and voltages in the circuit given below. So we have already discussed what is Ohm's law, KVL and KCL. So in this particular circuit, first we are going to find the voltages. To find the voltages, we should know what is Ohm's law. So we know Ohm's law is given as V is equal to I into R. So in this particular circuit, we are going to find the voltages across the various resistors. This 8 ohm resistor, this 3 ohm resistor and the 6 ohm resistor. So to find the voltages across these three resistors, we are using Ohm's law. So the the voltage flowing through this resistor is given as V1, which can be written as V1 is equal to the resistance value is 8 ohm and the current flowing through this resistor is I1. So it is written as 8I1. And the voltage across this 3 ohm resistor is given as V2, which can be written as V2 is equal to 3 into the current flowing through this resistor is I2. So 3I2. And the voltage across the 6 ohm resistor can be written as V3 is equal to 6 into the current flowing through this resistor is I3. So 6I3. By this three equations, we can find the voltages across the various three resistors. To find these voltages, we need to find what is I1, I2 and I3. In order to find I1, I2, I3, we are going to use Kirchhoff's current law and Kirchhoff's voltage law. So, we are considering the circuit as in two loops, as loop 1 and this one as loop 2. So now we are going to apply KCL at this node A. So when we are apply KCL at node A. So at node A, we know current entering is equal to the sum of current leaving. So I1 is equal to I2 plus I3. This can be written as I1 minus I2 minus I3 is equal to 0. Now, we are going to apply KVL in loop 1 and in loop 2 to find the current values. I'll explain how. When we are applying KVL at loop 1, I am writing loop 1 as L1. We are seeing the current flow. So the current flow in this loop is in this direction. So we are going to see whether it is positive 30 volt or negative 30 volt. So it is from minus to plus. So we are considering as 30. And the current flowing through this resistor is from minus to plus. So it is minus V1. And here also it is plus to minus, so it is minus V2 is equal to 0. So we have found two equations, that is V1 is equal to 8I1 and V2 is equal to 3I2. We are going to substitute these two values in this equation. We know V1 is equal to 8I1 and V2 is equal to 3I2. So, this equation can be written as 30 minus 8I1 minus 3I2 is equal to 0. Now, we are going to apply KVL in loop 2. I am considering L2 as loop 2. So we are going to see the current direction. It moves in this direction. So in this resistor, it is from plus to minus. So it can be written as V2. And in this resistor, the current flows in this direction. So it is plus to minus. So it is minus V3 is equal to 0. So it can be written as V2 is equal to V3. So now we are going to substitute the V2 values. We know V3 is given as 6I3. Now we are substituting the values of V2 and V3 in this equation. So we get 3I2 is equal to 6I3. Now we are going to consider, now we are going to take, in terms of I2. Likewise, that is, we are going to take I3 in terms of I2. So I3 can be written as 6 by 3 I2. So which in turns into I3 is equal to 1 by 2 I2. Let's consider this equation as number 1. This equation as number 2. And now we are also going to write I1 in terms of I2. So which can be written as, from this equation, 30 minus 8I1 minus 3I2 is equal to 0. So we are going to take I1 in one side. So minus 8I1 is equal to minus 30 plus 3I2. So I1 is equal to, we are going to multiply the whole equation by minus 1. So it is as 8I1, 30 minus 3I2. So I1 can be written as 30 minus 3I2 divided by 8. And let's consider this as equation 3. So we are going to substitute equation 2 and 3 in 1. That is, we are going to substitute the values of I1 and I3 in this particular equation, which we found using KCL. So which can be written as I1 is considered as 30 minus 3I2 by 8 minus I2 minus 1 by 2 I2 is equal to 0. Now we understood, right? We took I1 and I3 in terms of I2 so that we can find the value of I2, and later we can substitute in the particular equations to find the various current values. So when we are solving this equation, that is 30 minus 3I2 divided by 8 minus I2 minus 1 by 2 I2 is equal to 0. When we solve this equation, we are going to take LCM. So it is 8, 30 minus 3I2 minus 8I2 minus 4I2 is equal to 0. When we are solving this equation, we get 30 minus 15I2 is equal to 0. So I2 is given as, we get as I2 is equal to 2 ampere. So we are going to substitute I2 is equal to 2 ampere in 2, 3. So we get the values of I1. So I1 is equal to 30 minus 3 into 2 divided by 8. So I1 we get as 30 minus 6 by 8. So I1 will be 3 ampere. Now we are going to find I3. We know I3 is equal to 1 by 2 I2. So 1 by 2 into 2 is equal to 1 ampere. So we found the values of I1 is equal to 3 ampere, I2 is equal to 2 ampere, and I3 is equal to 1 ampere. Now we are going to substitute these three values in equations where we found voltage V1 is equal to 8I1. 8I1. So V1 will be 8 into 3, 24 volt, and V2 is given as 3 into I2. Yeah, we found it, right? 3 into I2. So V2 is equal to 3 into 2, 6 volt, and V3 we found it as 6 into I3. So 6 into 1, so 6 volt. So V1 is equal to 24 volt, V2 is equal to 6 volt, and V3 is also 6 volt. And we also found I1 is 3 ampere, I2 is 2 ampere, and I3 is 1 ampere. So I hope you understood how to find values of voltage and current in a circuit using Ohm's law, KVL and KCL. Thank you.